Hello grade 6, this is Miss Susan. Today's topic is about patterns in data. Lesson 13.1. And our essential question is:
how can you describe overall patterns in a data set?
So, today's topic we're gonna learn the patterns of data. That will help us to describe and summarize any set of data or any graph. So, it is some mathematical expressions and definitions that will help me to describe any set of data or any group of data. So, let's start and see.
Let's look for patterns in data from a dot plot.
Let's read first example together.
Many lakes and ponds contain freshwater fish species such as bass, pike, bluegills, and trout. Jacob and his friends went fishing in a nearby lake. The dot plot shows the sizes of the fish that the friends caught. What patterns do you see in the data?
So first,
let's unlock the problem.
this is our example here, and this is the givens here. It's a dot plot. It's a type of graph describing data by using or dotting plots. Okay, so it's describing the number of fish that Jacob and his friends caught. So, like for example, they caught 2 fish with the length 5 inches, 2 fish with the length 6 inches, 1 fish with the length 7 inches, and 1 fish with the length 8, and none with the length 9, and none with the length 10, and 2 fish with the length 11, 3 with the length 12, 3 with the length 13, and 1 only with the length 14. So, what patterns can we use to describe this set of data? So, let's unlock the problem and figure it out.
To identify any patterns, let's analyze the dot plot. To determine patterns from the dot plot, look at where the dots occur. First, look for gaps within the data. What's a gap? A gap is an interval that contains no data. Are there any gaps in this dot plot?
What are the intervals that contains no data? What are the numbers that contains no data? Here, it's 9 and 10. So this is the gap between the group of data. So we have gaps.
Yes, there's a gap from 9 to 10. Now, look for clusters within the data. What's a cluster? A cluster is a group of data points that lie within a small interval. Are there any clusters in this dot plot?
Okay, so clusters are a group of data points, okay, within the gaps. So we have here a group of data points. We have here group of data points. So they are the group of intervals that contains data. We call it cluster. So the group of intervals that contains data, we call it cluster. So we have 2 groups of data here within the gap. So we have 2 clusters.
Yes, there's a cluster from 5 to 8 and from 11 to 14. So this means that there were no fish from 9 to 10 inches long, and there were 2 clusters of fish measuring from 5 to 8 inches long, and from 11 to 14 inches long. You can use the dot plot to determine the mode of the data. Remember, the mode is the value that occurs most often in the set of data. How does a dot plot show the mode or modes of data? If the data have one or more modes, they're represented by the highest column or columns in the dot plot. Do the data have any modes?
So what is the number that most oftenly happen here, which has the highest column in this dot plot graph? Yes, we have here 2 modes, because we have 12 and 13. They both have the highest column in this dot plot. They both have 3 fish. So we have 2 modes, 12 and 13. They are both most oftenly happen, and they are both have the highest column in this graph. So the modes are 12 and 13.
The modes of the data are 12 and 13 because they have the highest columns and are the same height. This means that the group caught more 12 and 13-inch fish than any other size.
So again, to recap, what are the patterns that we learned about in this example? We learned about gaps, and gaps are the intervals that contains no data, which is here 9 and 10. We knew about clusters. Clusters are the numbers, group of numbers or group of intervals that contains data. We have two clusters, cluster here and cluster here, and we learned about the mode, and the mode, which are the data that is most oftenly happen, which has the highest column in the dot plot, and we have two modes, which is 12 and 13. Let's move to another example and learn about other patterns of data.
Let's analyze patterns in data that are displayed in histograms.
Let's read together the example.
Erica made this histogram to show the weights of the pumpkins grown at her father's farm in October. What patterns do you see in the data? First, look for peaks in the histogram. What's a peak? A peak is the high point of the graph. Are there any peaks in this histogram?
The peak is the top or the highest point in the histogram. Where is the highest point here? That's it. Excellent. It happened between 21 to 30. So we have one peak here.
Yes, there's a peak between 21 and 30. So the interval representing the greatest number of pumpkins is for weights between 21 and 30 pounds. Now, look to see how the data change over the intervals. The change over the intervals refers to each interval showing a different amount. Where does the number of pumpkins increase on the histogram?
Changing in the graph or changing between intervals can be described by two words: increase and decrease. Increase became bigger, and decrease means became smaller. So, where is the graph? Where are the intervals that the graph increases here? Yes, it increased between 0 to 30. And where are the intervals that the graph decreased here, or the data in the graph decreased here? It began to decrease after 30 to 50. The data here decreased.
The number of pumpkins increases from 0 to 30 pounds. Where does the number of pumpkins decrease on the histogram?
Decrease means became lower or smaller, so the graph here became smaller from 30 to 50.
The number of pumpkins decreases from 30 to 50 pounds. Finally, let's see if the histogram has symmetry. What's symmetry? A figure has line symmetry if you can draw a line through it so that the two parts are mirror images of each other. Does the histogram have any symmetry?
So, symmetry means if you make any line of symmetry in the middle of the shape and you fold the shape into two parts, the two parts will exactly match. So, if you imagine a line of symmetry here just in the middle of the graph and you fold the two parts of the graph above each other, will they match? I think yes. So, there is a symmetry in this graph.
The histogram has symmetry at the interval 21 to 30. So the data values increase to one peak in the interval for 21 to 30 pounds and then decrease. The data set has line symmetry about the peak.
So, in this example, we learned another three patterns. We learned about peak, which is the highest point in the graph, and we learned about changing in data, which using the words increase and decrease, and we learned about symmetry, which use a line of symmetry to see how the data change around it and how the two parts of the graph can match above each other. So, Let's see another example.
The dot plot shows the number of paintings students in the art club displayed at the art show. What patterns do you see in the data? Let's determine whether there are any gaps, modes, clusters, and symmetry in the data. Are there any gaps in the data?
Gaps are the group of intervals that contains no data at all. So if you can look here, you have three numbers that contains no data at all, which is 4, 5, and 6. So yes, we have a gap between 4 to 6.
That's correct. The data have a gap from 4 to 6. Now, what's the mode of the data?
The mode is the data that most oftenly happen, which has the highest column in this dot plot graph, which it's 2.
That's correct. The highest column shows that the mode of the data is 2. Next, look for clusters. Are there any clusters in the data?
Clusters are the group of numbers or group of intervals that contains data. So we have here cluster between 1, 2, 3. But I can consider 7 as a cluster. 7 is just one number. It's not a group of numbers or group of intervals. So I can't consider 7 as a cluster. Only 1 to 3 is a cluster because it's a group of numbers or group of intervals. So yes, from 1 to 3 we have a cluster.
That's correct. There is a cluster from 1 to 3. Notice that there are no data values near 7, so 7 doesn't count as a cluster. Now, look at the dot plot for symmetry. Is there symmetry in the data?
Okay, can you imagine to put a line of symmetry just in the middle of this graph? Will it match the two parts exactly? No. So there is no symmetry in this graph or in this line plot.
That's correct. There's no symmetry in the data. Now, use the information about gaps, modes, clusters, and symmetry to answer questions about the art club. How many paintings did each student display in the art show?
3 students display 1. 4 students display 2 paintings. 2 students display 3 paintings. 2 students display 7 paintings. So it is either 1 or 2 or 3 paintings or 7 paintings. So it's 1, 2, 3 or 7.
That's correct. Each student either displayed 1, 2, 3, or 7 paintings. How many paintings did the most students display?
The most students display 2, which is the mode of this graph, because we have 4 students, which is the highest column here, displayed 2 paintings. So the mode is 2.
That's correct. The most students displayed 2 paintings. What number of paintings was not displayed by each student?
This is the gap. What are the numbers that is didn't displayed in in this club? So it is 4, 5, and 6 because we have no data in these intervals. So the gap or no student displayed 4 or 5 or 6 paintings.
That's correct. No students displayed 4, 5, or 6 paintings. So the data set shows that each student displayed 1, 2, 3, or 7 paintings. The gap shows that no student displayed 4, 5, or 6 paintings. The highest column shows that the most common number of paintings displayed by each student was 2. Now try your homework on your own with the personal math trainer. It includes the exercise you saw at the beginning of the lesson.
Thank you, grade 6, for watching. Hope that you
Thanks for
understood the
helping me
lesson.
describe the overall patterns of the park ranger's data. See you soon!
See you soon. Bye bye.